Hi AP Chemistry students. I'm going to show you how I would solve this particular AP classroom topic question. It is originally a multiple choice, but we're going to solve it as if it is a problem. So it shows the dissolution of barium iodate, and it reads, according to the information about the dissolution of barium iodate shown above, the correct value of S, and that's the molar solubility, the molarity that the concentration that will dissolve of the barium iodate, which is a very insoluble salt. So it says the correct value of S, the molar solubility of barium iodate, can be calculated using what mathematical relationship? So we're going to figure that out. You'll notice I put a rice table down here, and I like to do that, but I'm going to do something else first. The first thing I'm going to do is just figure that I have to have a KSP, and so I'm going to write the KSP. So I know the KSP for this particular dissolution is equal to 4 times 10 to the negative ninth. I also know, because of the law of mass action, that it's going to be equal to the barium ion concentration times the iodate concentration raised to the second power, because that's the stoichiometry. You've got the 2, and you got to raise to the power. Okay, now I have to figure out what the correct value of S is, and I need to relate it so I can put it in this expression. So first thing, I usually like to write a rice table just to remind myself that this value right here is just a constant. So it doesn't really change that much, so it's not part of the equation. Very small amount of this is going to dissolve, and initially we're going to have 0. But as a small amount dissolves, because this is a 1-to-1 stoichiometry relationship, the amount of change is going to be plus however much dissolves, the solubility. On the other hand, since this is a 1-to-2 ratio, this is going to be twice that. Okay, so the equilibrium concentrations are just going to be S and 2S. Now I can put it up in this relationship here. I can see that the KSP, which is 4 times 10 to the negative ninth, is going to equal S, because that's this concentration. And this is going to be 2S squared, all right, equals 4 times 10 to the negative ninth. So the mathematical relationship is going to be, doing this is going to be 4S cubed equals 4 times 10 to the negative ninth. If I divide 4 by 4, I'm going to move it over here. S cubed is going to equal 1 times 10 to the negative ninth. And so if you don't want to put this in your calculator, but you're going to take the cube root of both sides, okay? And the cube root of both sides is just going to be 1 times 10 to the negative third molar. And that is going to be your solubility. And that's how I would solve it.